This is Tom Salemi at OIS at AAO. I'm here with Chris Pulling, CEO of MicroOptx. Thanks for joining us today.
Thanks for having me.
Now you are in a very hot space. You're kind of functioning in the MIGS space. Can you tell us a bit about what your device, what the name is and what it does?
Yeah, so our device right now is called the Brown Glaucoma Implant. Until we come up with something a little catchier, named after the founder. And we're in the MIGS space, but instead of shunting to other enclosed spaces inside the eye, we're shunting directly to the tear film of the eye, to the surface of the eye, and in that way, hoping to avoid the problem of membrane growth over the end of the device, and also because we're going to the surface of the eye, the only source of resistance to the aqueous flow is the internal filter we've engineered inside the device. Mm-hmm. And since the rate of flow into the anterior chamber is somewhat constant, or at least known, and we know what we want the intraocular pressure to be to halt further damage to the optic nerve, we use a simple physics equation to set the resistance to achieve that intraocular pressure. So
is that what is the origin of that technology, and is diverting it to the surface of the eye? Has that been approached by anyone else, or has that been a concept that someone else has thought of?
It's been a concept that was proposed in probably mid-1990s, but no one had actually attempted it yet or figured out a way to do it. Our physician inventor, Dr. J. David Brown, was a longtime glaucoma surgeon in Minnesota, at a time one of the highest volume glaucoma surgeons in the state, and he kind of conceived of the idea, took some time off from practicing to develop it, and then he wasn't quite sure what to do with it at that point. I was running a company previously, a contract medical research group, and he came to our lab and asked for a little help, and we helped him about 3 years ago. Then he put the idea on the shelf again and took a chief of ophthalmology job at the VA hospital in Minneapolis. And I sold my other company and called him up and said, let's see if we can form a company, raise some money, and get it to patients. So.
And you've raised a small amount of money, just a few $1 million.
Yeah, just under $3 million. Just under $3 million, but the device had already been pretty well engineered. It was the inside of the device, the flow channels and the surface chemistries, all of that very well characterized, done. We want to optimize the interface with the surface of the eye to make it as biocompatible as we can. So that we want the ocular connective tissue to grow around the device but not over. Mm-hmm. And so we just finished a series of optimization studies to do that. We're starting our GLP safety study on Wednesday next week. Oh, we've had a couple rounds of discussions with FDA. We're actually going to conduct our first human feasibility study here in the U.S. under an IDE. And we're hoping to get that going in around July of next year. We've also have filed a lot of new intellectual property recently on dry eye and ocular surface diseases. Mm-hmm. Because aqueous is coming to the surface of the eye, it's very therapeutic for dry eye or ocular surface. And so many glaucoma patients develop ocular surface disease from the medicated drops. So we file IP around there, and also we just saw the Alcon presentation. It also turns out when the aqueous starts as blood, goes through the filtering system, and what's left is a clear lubricating substance. The glucose molecules are small enough to not be filtered out. So the aqueous has the exact same concentration of glucose as the blood does. And so we also just filed a whole bunch of intellectual property on the idea of continuous glucose monitoring now that we're making the aqueous accessible at the surface of the eye.
Well, this is obviously a very hot space, and you're making a lot of great progress.
Yeah, well, thank you.
Great. Yeah. Well, thanks for taking a few minutes with us.
You bet, anytime.